Okay, in this question we're doing a vertical dilation of a function with a fraction. So let's have a look here. We've got dilate ln x. Now many of us know what ln x is. Ln x is basically the same as log base e x. So log base e is the same as ln. So we want to dilate ln x vertically by a factor of 1/3. Now what is 1/3 going to do? Well, the 1/3 is going to be put in front of the function as represented by the letter k. So we got y equals k fx. Now if k is greater than 1, it's a big number, what's that going to do vertically? It's going to stretch it, isn't it? So k is greater than 1 is a stretch towards the y-axis and up. And when it's a fraction between 0 and 1, then it's going to be compressed vertically. So right now we've already got the function ln x or log base e x already drawn. So this is kind of the trajectory, the way it looks, and it cuts through the point 1, 0. Now what we want to do is draw it, or actually come up with the dilation of this by 1/3. So the 1/3 is the k right there. So we can write down k equals 1/3, which is the fraction. We know it's going to be compressed, so it's going to be more squashed. And we know it's going to be part of the ln x. So that means if we put it together, the function y is equal to 1/3 ln x. So the 1/3 just goes in front, just like the k in front of the function. So that's what we have, but we've drawn y equals ln x. How will this look? Well, I imagine, based on the word compression, that it's going to go similar to this, but it's going to go under the red curve of ln x because it's more squashed, it's compressed vertically. It's not going to go up, it's going to go more down, so it'll be more squashed. So the way we're going to confirm that is by doing just a small table of values, just a couple of points, 3 points, and then we'll be able to identify and confirm that in fact it is more squashed or more compressed. So the points I'm going to pick in order to draw 1/3 ln x, let's just go between 0 and 1 right in here. We'll pick 1 and then maybe 3 up here, 3 points like that. So let's go ahead and do that. So we'll pick the points, we'll start off with x, then we've got ln x, and then 1/3 ln x. Just to pick a few points. Okay, the first point that we can start off with, as I said, between 0 and 1, let's go 1/2. You have a half. We have x equals 1. And let's go over here to 3 or maybe 4. We'll go to 3. Okay, let's substitute now. You use your calculator. We want to go ln 1/2. Well, ln 1/2 on your calculator is approximately minus 0.7. Okay, let's put in 1. ln 1 on your calculator will be 0, as confirmed already by that point right there. Cuts right through 0, 1, 0. Let's go over here. ln 3 on your calculator is approximately 1.1. Okay, let's put 1/3 in front. Let's multiply all of these guys, the ln x, by 1/3 because it's a constant right in front. So 1/3 of 0.7, that's going to be negative approximately 0.2. 1/3 of 0 is still 0, so they both cut through 1, 0. And then 1/3 of 1.1, 1/3 of that will be 0.36, 0.36 or 37. Let's round it up, 0.37. Now we can take these points, plot them on there, and take a look at how compressed 1/3 ln x actually is. So 1/3 ln x, let's go for a half negative 0.2. A half negative 0.2, that's going to go approximately there. Then we have 0, 0, it's going to go through 1, 0, sorry, and then 3.37. Then 3.37, 0.3 of 1, that should be about there. So if I join the dots, it's going to be a bit squashed in here. It's going to look something like this. Something like that. There you go. And that right over here is 1/3 lnx. So what do you notice about it? Do you notice that it's more, is it more compressed? Definitely. It's more compressed because it's further away from the y-axis. It's more compressed and it looks closer to the x-axis. So you can see it's a lot lower. By how much? Well, this is a good rule of thumb because the y values have gone down. What that means is if I draw a vertical line through here, the point, let's say I pick a point up here at 3, right there at 3, 1, and compare it to this point right here, just below, right there, this point here. If I compare those 2 points, you will see that the distance between the x-axis and that point we just got there, which is 1/3 lnx, and we compare it to the lnx up there, it's approximately 1/3 the distance between there and there. No matter where you draw a vertical line, this will always be 1/3 of the total distance between the horizontal axis and lnx. So that's another good rule of thumb to recognize when you're drawing these guys. So again, if I dilate lnx vertically by a factor of 1/3, it will equal 1/3 lnx and it will be compressed.